This is the insides of a 5-volt USB power supply, and I took this one apart, I think, because it had one of the 2-pin European type plugs on it. It was a Wall-Wart with the European style plug, and I didn't really need it, so I thought I would tear this one down and see what's inside. And it has some quite interesting characteristics, so I thought I might describe them here in this video. So one of the things that interested me the most was the relationship between the low power section on this side and the high power section on this side. So if you look at the underside of the board, there's quite a nice big gap here between the live side over here and the low voltage side here. So quite a nice big safety gap, and there are several components that cross that gap. So of course we have a small transformer, so the transformer's got the main power delivery system between the two sides, and then there's this capacitor which goes from the neutral on this side to the negative on this side. So that's to reduce electrical interference, from what I understand. So the high frequency components that leak through to the transformer on this side have a low reactance path to go back to where they came from. So it's about suppressing high frequency electrical noise from the equipment that you're charging. So there's the capacitor there, and then finally there's the optical encoder here. So this also bridges the gap between the two sides, and that's a feedback system to regulate the voltage on this side. So inside here we have a LED, which is lit up by the circuit here, and on this side we have an open collector transistor. So this has the ability to optically switch from one side to another without there being a direct electrical connection between the two sides. So I reverse engineered this circuit, and let's have a look at that. Using an idea that I saw on the Big Clive video, I've taken a photograph of the bottom of the board, and then I've used this to draw in the various components that I see on the top side of the board. So in this way I can work out what's connected to what. And you can see this bit that I'm interested in here, the relationship between the two sides of the circuit. So here we've got the optical encoder at the top, we've got the suppression capacitor in the middle, and then we have the small transformer. So we have a winding on this side providing AC into the low power side of the circuit, and over this side there are two different windings. So one of these is for power delivery and one is a feedback mechanism. So let me show you the circuit for that. I've separated out the different components of the circuit, so let's look at them one by one. First of all, we've got the current coming in from the main, so we've got live and neutral. We've got a bridge rectifier which is made of 4 discrete diodes, as you see here, and then we have this 1 ohm resistor, and the purpose of the 1 ohm resistor is to burn out if too much current flows through the circuit. So this is a safety mechanism. So that's this resistor down here, in fact, on the board. And looking at the low power side of the circuit, so we have the USB connector here, which is the output to the phone or whatever you're charging. So we have a positive and a negative, and then the D plus and D minus pins here, they're looped together. You can see on the circuit board that they actually just connect together using part of the printed circuit board, using a track there. So this method of connecting the inner two pins together is from the DCP specification, which is the device charging profile, and this is one of the many different USB specifications that's in use at the moment. And DCP tends to be implemented by Chinese type products, so big companies like Sony and Apple and Samsung all seem to have their own unique standard. So a very common one is the Apple one, which uses resistors to present different voltages on the 2 pins, but the DCP specification is much simpler than that. It just shorts those pins out, and that gives a clue to the equipment that you've plugged in that these pins here, the plus and minus pins, can source 1.5 amps. So this is a 1.5 amp power supply unit, but not for Apple devices. So we have the USB connector. There's also there's a big capacitor. I notice I've forgotten to add a line there. So there's a big smoothing capacitor here. There's also the red LED which shows that the power is on, and then this is the quite interesting bit here. So we've got the secondary of the transformer with a single diode. So this is crudely smoothing AC into DC, so you'll get this kind of lumpy well, let me see, how will it look? Yeah, so the negative parts of the wave will be suppressed, so the DC will look something like that, and the negative part of the sine wave has been cut off by the diode. So we've got kind of lumpy DC coming out of here. And this interesting circuit here is how the feedback works through the optical encoder. So we have a Zener here, which seems to be a 5-volt type. So this circuit here, the Zener will drop 5 volts, and if there's more than 5 volts on this rail here, then you'll get a slightly raised voltage across this resistor, and that seems to be what feeds a bit of extra current into the LED inside the optical encoder. So it'll then be switching this transistor and allowing the transistor to conduct on the high voltage side. So this is a mechanism so that when the voltage gets too high on this side, you can feed that back to the other side, and then some action is taken on the other side of the transformer. I'll just mention the suppression capacitor here. You can see it's actually a little ceramic type, which is not great, because if that shorted out, then obviously you'd have the neutral and the negative interconnected, which you might not want. Although, I mean, if you touch the neutral, you shouldn't really get an electric shock, but it doesn't seem like an ideal situation. Now, if they'd spent a bit more money on this design, they would probably put a Class Y capacitor in here instead, which is really designed to do that job. And if you see on the printed circuit board here, it actually says C4CY, so maybe that's implying there should be a Class Y capacitor in there. So we have the suppression capacitor here that's linking the high voltage side to the low voltage side. So let's have a look at the high voltage side. I've put all of the interconnections on this side, so you can see there's the secondary winding here, which is interconnected with one winding here in this circuit next to the optical encoder, and then another winding here, which is obviously the main power winding, which is going to a switching transistor. So we have the optical encoder here controlling this left-hand part of the circuit, and there's the suppression capacitor right at the bottom there, connected to the negative side. So I think what we have here, this is the oscillator circuit using the one of the primary windings on this transformer, and this can be controlled by the transistor within the optical encoder. So this is the thing that's responding to the over voltage signals coming from the low voltage side of the circuit. And then the collector of this circuit is going into what looks like an amplification circuit. So this is like a single stage amplifier, which is then feeding the main switching transistor. You can see the X13003, it's this larger transistor here. So that's the switching the main current. So as the collector to emitter path switches here, we're actually switching the current back and switching the current up and down on the main primary part of the winding, which is then transferring energy to the secondary on the low voltage side. And here you can see on the power rail, so this is the 360 odd volts that come out of the bridge rectifier that we saw right at the beginning. So it's really quite a simple circuit. I mean, there are two amplification or switching transistors here, and then there's another transistor which is integrated in the optical encoder. So for a really very small component count, this is quite an effective 5-volt design, albeit with some slightly strange design choices. But there we go. I mean, that's a quick summary, quick teardown of one of these cheap USB 5-volt power supplies, and many of the cheaper devices that you come across will have a very similar design, a very small component count.